Hey there, and welcome to The Explainer. Today we're going to take one of those pages from a math textbook that looks super intimidating, Pythagorean Identities, and we're going to make it totally clear. Because by the end of this, you'll see they aren't just random formulas to memorize, they're actually super powerful tools, and they all come from one simple familiar idea. So it really all boils down to this question. We all know the Pythagorean theorem, right? It's for right triangles. But what in the world does that have to do with points on a circle, or the functions that make waves? And the answer? Well, it turns out it has everything to do with it. This connection is the master key that unlocks the whole thing. So here's the game plan. We're going to start by linking that old theorem to the unit circle. Then we'll lock in the core identity, see how we can easily create the other two from it, and then we'll put them to work. And stick around because we're going to finish with a really cool bit of trivia about where the word tangent even comes from. All right, first up, the foundation. Let's start on some solid ground with something you probably already know really well. Yeah, you know this one. A squared plus b squared equals c squared. It's probably burned into your brain. But what happens when we take that classic triangle and drop it into a very, very specific place? Okay, so imagine we take that triangle and put it right inside the unit circle. All of a sudden, that A side, the adjacent one, that's just the x-coordinate, which we call the cosine of the angle. And the b side, the opposite one, that's the y-coordinate, or the sine of the angle. And c, the hypotenuse? Well, it's just the radius of the circle, which is always 1. So a squared plus b squared equals c squared just transforms. It becomes cosine squared plus sine squared equals 1 squared. And that right there, that brings us to the core identity. Seriously, think of this thing as the master key. Once you have this one, you can unlock everything else. So here's the thing you absolutely have to remember. Sine squared of any angle plus cosine squared of that same angle will always, always, always equal 1. And this isn't just some neat party trick, you know? It's a fundamental property of how this stuff works, and it's an incredibly powerful tool for simplifying things that look messy. Okay, now for the best part. You absolutely do not need to memorize 3 different formulas. You just need to know that one we just found, and then you can use a little bit of algebra to create the other 2 whenever you need them. Right, so if this is our parent identity, where do the other 2 come from? It's not magic or anything, it's just division. Okay, so we start with our main guy, sine squared plus cosine squared equals 1. Now let's just divide everything, every single piece, by cosine squared. So sine squared over cosine squared, that's tangent squared. Cosine squared over itself, that's just 1. And 1 over cosine squared, that's the definition of secant squared. And boom, just like that, there's our second identity. All right, you ready? Let's run that play again. Back to the original, sine squared plus cosine squared equals 1. But this time, we divide everything by sine squared. Sine squared over itself is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared, cosecant squared. And there we have it, the third identity. See? One single formula and 2 simple division tricks. And now we've got a whole family of 3 super powerful tools. Okay, that's all cool theory, right? But so what? What's the point? Well, this is where the magic happens. This is where we see how these identities can take something that looks like a total mess and make it like beautifully simple. All right, check this thing out. I mean, look at it. It looks complicated, right? You've got different functions, squares, subtractions, multiplication. Trying to simplify this thing as it is, it'd be a complete nightmare. But now we've got our secret weapons. And this is a key point, like right from the textbooks. The real power isn't just knowing the formula, it's knowing how to shuffle the pieces around. So let's do that. Let's shuffle the pieces of our other 2 identities. If you move the 1 over, you'll see that secant squared minus 1 is just tangent squared, and cosecant squared minus 1 is just cotangent squared. And just like that, our ridiculously complicated expression becomes tangent squared times cotangent squared. Way better, right? So, what happens when you multiply tangent squared by cotangent squared? Well, think about it. Tangent and cotangent are just flips of each other. They're reciprocals. So when you multiply them, you get 1. Which means their squares also multiply to, 1. The whole big, scary thing just collapses down to the number 1. Now that is the power of these identities. Okay, for this last part, let's dive into something really cool that's been hiding in plain sight this whole time. The name of the tangent function. It's not random at all. It's pure geometry. I'm serious, have you ever actually stopped to wonder about that?
Why on earth is it called tangent? Turns out the name itself is the biggest clue.
Because, get this, the value of the tangent of an angle is literally the length of a line segment that is tangent to the unit circle. It's a direct, visual, geometric thing.
Okay, this is the big aha moment. Just follow me here. In the triangle that gets formed, the side next to the angle, the adjacent side, that's just the radius of the circle, so its length is 1. And what's the definition of tangent? It's opposite divided by adjacent. Well, if the adjacent side is 1, then the tangent is just the length of the opposite side. And guess what that opposite side is? It is that tangent line segment. How cool is that? The name isn't just a name, it's a description.
So that brings us full circle, literally. What we've seen today is that these 3 identities aren't just abstract rules you have to cram into your brain. They're the Pythagorean theorem, just wearing a different hat. They're the fundamental geometry of a circle, spoken in the language of trigonometry. So I want to leave you with this question. Now that you know these identities are basically just relationships born from a simple circle, how is that going to change the way you look at the next gnarly problem you come across? What other hidden connections are just waiting for you to find them?